Hello folks, welcome back to Precalculus. Today we're continuing Chapter 5, Section 3, and we're going to talk about reciprocal trigonometric functions, specifically cosecant, and then in a moment we're going to talk about secant. Okay, please know that this structure of this lesson is going to follow the same structure as the previous lesson, in that we're going to kind of go over secant, and then I'm going to turn you loose to do, we're going to go over cosecant, and then I'm going to turn you loose to do secant on your own. Okay, so just so you guys have that kind of in your head, you can start thinking and planning. So let's talk a little bit about reciprocal functions. Okay, reciprocal functions meaning 1 over a function, okay, is going to have asymptotes at the original x-intercepts, which should make sense to you because the original x-intercepts of sine are 0 values, and 1 over 0 is undefined, thus giving us asymptotes. Okay, so think about it, wherever sine is 0, cosecant is going to have an asymptote. Even if it's shifted up a value, say up 9. Let's say we shift the cosecant up 9. You'll see that happen here shortly. But undefined plus 9 is still undefined. So no matter what, wherever sine had x-intercepts, the original x-intercepts, cosecant is going to have asymptotes. So to do this, and to see this graph, it's actually very simple. We're going to go ahead and just graph sine. So let's go ahead and graph sine. Let's throw an amplitude of 1 on there. Just a real quick graph of sine. I'm going to draw a couple periods here so you guys can see big picture how the cosecant graph behaves. Okay, make sure my points are all good. Beautiful. So now, wherever sine has an x-intercept, gotta leave an extra one there, cosecant is going to have a vertical asymptote. Go ahead and draw these. It's important to note, while we're doing this, we can talk, that these are where the original x-intercepts are. So if I was, like I talked about earlier, if I was taking my sine graph and moving it up, I would still use wherever these midpoints are because these are the original x-intercepts. Okay, so now let's take a look at this value 1. 1 over 1 is still 1. We can leave that value right there. It's going to hold true for any value that's 1. We got a few of those. Now let's take a look at this value down here, these negative ones. 1 over negative 1 is still going to be negative 1. So these values are actually going to stay in place. Now, let's talk a little bit about the behavior of a reciprocal graph. Well, think about it. The sine graph, which I can, draw in pencil real light here. I'll just draw one of the periods here real light of this sine graph. As we look at it, as we approach 0, so this sine graph from this peak here, from this maximum, each way it's getting closer and closer to 0. Well, as you reciprocate values that are getting closer and closer to 0, the reciprocal of values that get closer and closer to 0 goes to infinity. So this graph is going to shoot off to infinity. This reciprocal function cosecant is going to shoot off to infinity. And the same thing is going to hold true underneath here, except the values are negative, so it's going to shoot off to negative infinity. And that's going to be how we get the shape of our graph. It's going to repeat just like the sine. Looks like a bunch of mini parabolas, but they're not, because they are bounded by these vertical asymptotes. And there's the graph for cosecant. Now, let's talk a little bit about the characteristics of it. Well, first notice that it's made from the sine graph, okay, and I forgot to label my period. but it's going to have the same period as a sine graph, 2 pi, meaning that we're still going to be using the equation 2 pi over b to find the period of cosecant. Same is going to hold true for secant. The range, notice the only place where it doesn't exist is here between -1 and 1. So our range is going to be negative infinity to -1, union with 1 to infinity. Now the domain is broke up every pi, right? Every single pi. So the domain is going to be 0 to pi, and then pi to 2 pi, we're going to exist, and then so on and so forth. Same with the vertical asymptotes. They're going to be separated every pi. So vertical asymptotes are going to be x equals 0, pi, 2 pi, 3 pi, etc. And just like the sine graph, this function is symmetric to the origin. So there's your cosecant graph, and we'll be sliding it around and stretching the amplitude and everything. And when we do those things, we're going to be affecting the sine graph, which is then going to affect the cosecant graph. So what I'd like you guys to do right now is go ahead and pause the video and derive the secant graph on your own by first drawing cosine, finding where the asymptotes are, and drawing it from there. So go ahead and pause your video, give yourself a few minutes, and fill out this page. Okay, so now let's do some examples together. You see we have 2 examples. So just know that we are going to do the cosecant one together as a class, and then I'm going to ask you guys to do this one on your own. Okay. Notice the only slight difference here is this one is reflected over the x-axis. Okay, but let's jump to cosecant. Let's not get too excited here. So we know we're drawing cosecant, so we're going to be starting by drawing sine. Let's figure out what this period is first. The period is 2 pi over b, which is 2 pi over 5 is our b value. So you guys know how to divide fractions. You multiply and flip. So our period is 5. Our amplitude, and I use that with air quotes, but our amplitude is going to be 1/4. And now we can draw from there. Okay, we have no left, right, or up, down, which is very convenient for us this time. So let's go ahead and start drawing sine. So if I say sine's going to start at the origin, and there's 1, there's -1, our amplitude is 1/4. It's going to go over every 2 spaces. And this right here is 5. So we can keep drawing. Let's get in the habit of drawing a couple periods. There we go. Now we can see that we have an amplitude of 1/4. We've got a period of 5. And now it's just time to turn this sine graph into a cosecant graph by saying, where's my original x-intercepts? Because those are going to become my vertical asymptotes. Beautiful. We know that our peaks are going to stay our peaks and our valleys are going to stay our valleys. And then we just need to reciprocate those values. Maximums open up and minimums will open down. That's simple. And there we have our graph of cosecant. So take a moment at the end of this video, use the cosine graph to draw this secant function. Find your period, your amplitude. Don't forget to reflect over the x-axis. And I look forward to helping you guys in class. Make sure you get everything done. Have a great day.